Tesla reclaimed its crown as the world's top EV seller after BYD briefly held the title for just one quarter. But don't count BYD out yet. The Chinese automotive powerhouse has unveiled their revolutionary next-generation blade battery technology that's poised to transform electric vehicles forever. BYD's latest innovation enables unprecedented 1 megawatt charging capability for passenger vehicles, a quantum leap forward in EV technology. This groundbreaking battery isn't just an incremental improvement, it represents a fundamental shift in what's possible for electric cars, delivering enhanced safety, affordability, and dramatically faster charging times with 80% capacity achievable in record time. How did BYD accomplish this remarkable breakthrough? What makes their blade battery vastly superior to conventional options? Let's explore this game-changing innovation. The EV battery challenge. Electric vehicles have moved from future possibility to present reality, with adoption accelerating globally as consumers seek cleaner transportation and lower operating costs. However, several persistent problems have hindered wider acceptance. Traditional EV batteries utilize expensive materials like nickel and cobalt, significantly increasing manufacturing costs and keeping prices high for consumers. Safety concerns persist, as conventional lithium-ion batteries can overheat, creating fire hazards in extreme circumstances. Additionally, supply chain vulnerabilities affect production, with materials like cobalt primarily sourced from the Democratic Republic of Congo, raising ethical and availability issues. Rather than making minor tweaks to existing technology, BYD chose to revolutionize the entire approach. The blade battery revolution entered in 2020. BYD's original blade battery eliminated nickel and cobalt, instead using lithium iron phosphate (LFP) chemistry. This fundamental change delivered multiple advantages: enhanced safety during the notorious nail penetration test that causes most batteries to fail through thermal runaway. BYD's blade battery remained stable without fire or explosion. The battery maintained integrity even when crushed, bent, or exposed to extreme temperatures. Cost reduction. By eliminating expensive metals like cobalt and nickel, BYD significantly reduced production expenses, making EVs more financially accessible. Extended lifespan. The blade battery's durability surpasses traditional options with up to 5,000 charge cycles, dramatically outlasting conventional EV batteries. Next-generation breakthrough. BYD's newest blade battery iteration builds on this foundation with remarkable improvements. 27 higher energy density, increased from approximately 150 to 190 watt-hours per kilogram, allowing more power storage without increasing battery size or weight, translating to extended driving range in the same package. Accelerated charging. The new battery can charge from 30% to 80% in just 30 minutes using 110 kilowatts fast charging systems, addressing one of consumers' most significant concerns about EVs. Improved thermal management. The next-generation design generates less heat during charging, improving efficiency and further extending battery longevity. Engineering excellence. BYD's advancements stem from years of methodical research and development rather than sudden discovery. The company's comprehensive approach encompasses chemical innovation. By refining LFP chemistry instead of relying on traditional nickel-cobalt-manganese formulations, BYD created inherently safer, more cost-effective, and longer-lasting batteries. Vertical integration. Unlike competitors who rely on external suppliers, BYD controls its entire supply chain from raw materials to final assembly, enabling coordination and optimization impossible for other manufacturers. Thermal efficiency. The new blade battery fundamentally produces less heat during operation, reducing cooling requirements and boosting overall system efficiency. Industry disruption. BYD's innovation presents massive challenges for competitors like Tesla, Volkswagen, and General Motors. Cost pressure. By eliminating expensive metals and controlling production internally, BYD can offer competitive pricing that forces rivals to adapt or lose market share. Safety standards. The blade battery's exceptional safety performance raises consumer expectations across the industry. Charging convenience. With 30-minute charge times approaching the convenience of gas refueling, BYD removes one of the most significant barriers to EV adoption. Tesla has begun incorporating LFP batteries in some models, acknowledging the chemistry's advantages. However, unlike BYD, Tesla sources these components externally rather than manufacturing them in-house, potentially limiting cost control and innovation opportunities. Volkswagen and GM face even greater challenges, having invested billions in conventional battery technology. They must either maintain their current path and risk falling behind or undertake costly transitions to new technology platforms. Transportation transformation. BYD's next-generation Blade battery doesn't just represent corporate competition, it potentially accelerates the global transition to sustainable transportation by addressing key adoption barriers. Faster charging eliminates range anxiety and inconvenience. Solar costs make EVs financially accessible to more consumers. Enhanced safety builds consumer confidence and range matches or exceeds conventional vehicles. The stage is set for electric vehicles to reach price and convenience parity with gasoline-powered alternatives, potentially accelerating adoption beyond current projections. BYD's flying car revolution. In another stunning development, Chinese EV giant BYD has unveiled an affordable flying car priced at an astonishing $4,999, shattering industry expectations. This revelation comes as BYD's overall revenue has surpassed Tesla's for the first time, marking a significant shift in the electric vehicle landscape. The company's bold entry into aerial transportation at a consumer-friendly price point could democratize access to technology previously restricted to luxury markets. How did BYD achieve this breakthrough when competitors have only produced concepts with six-figure price tags? Making the impossible affordable. BYD has established itself as a leader in accessible clean technology, and this flying car represents their most ambitious effort to bring futuristic transportation within reach of everyday consumers. The announcement generated immediate worldwide attention, with tech enthusiasts, industry analysts, and potential customers astonished by the sub-$5,000 price, less than many premium laptops. This development continues China's pattern of leadership in emerging technologies, including artificial intelligence, robotics, clean energy, and now aerial personal transportation. By making flying vehicles financially accessible, BYD follows the historical path of automotive and aviation industries, which evolved from luxury to mass-market accessibility through innovation and scale. Design and functionality. Its flying car prioritizes practicality with a straightforward, functional design. The compact vehicle measures approximately 12 feet in length by 5 feet wide, weighing around 1,500 pounds, remarkably light for its capabilities. The cockpit features intuitive controls designed for ease of use by first-time operators rather than experienced pilots. The vehicle incorporates retractable landing gear and aerodynamic elements optimized for stable short-distance urban travel, with short takeoff and landing capabilities allowing operation from parking lots or small clearings without requiring runway infrastructure. Technical specifications. By electric motors. Consistent with BYD's environmental focus, the flying car operates quietly compared to combustion alternatives, making it suitable for urban and suburban environments. Safety features include automatic stabilization systems, altitude control limiting maximum height to approximately 1,000 feet, and emergency landing capabilities. Performance specifications include maximum speed, around 80 mph, flight time, 30–45 minutes per charger range, approximately 25–30 mile charging time, estimated 1 horse. Vehicle utilizes advanced lithium-ion battery technology from BYD's established electric vehicle program, with potential future integration of solar charging capabilities to extend operational range. The modest speed and range specifications reflect the vehicle's intended purpose for urban mobility rather than long-distance travel. Regulatory considerations. BYD has reportedly worked closely with Chinese authorities to ensure compliance with aviation safety standards. The vehicle's operation at relatively low altitudes helps avoid major airspace restrictions, though international markets would require additional certifications to meet local requirements. Extensive safety testing following both local and international guidelines has been conducted to establish the vehicle's reliability. As flying cars move from concept to reality, regulatory frameworks may evolve to accommodate this emerging transportation category. BYD's approach of creating an affordable, safety-focused vehicle could help accelerate regulatory adaptation. What do you think about these revolutionary developments from BYD? Are we witnessing the beginning of a new era in transportation? Drop your thoughts in the comments, subscribe to our channel for more cutting-edge tech news, and share this video with friends who need to see what's coming next in mobility.